All right, so now we'll have Mattia Belluco, who is going to be speaking about CephFS and looking for the Swiss Army knife of POSIX file system. I like that title. Let's hear it for.
Thanks. So thank you, and good afternoon, everyone. We'll spend the next 20 minutes actually looking at our experience with CephFS. So I'm Mattia Belluco. I'm from the University of Zurich. I work for the Service and Support for Science IT unit. That has been a unit that was created in 2014 to help actually researchers with the compute-intensive science. We provide support to run simulation and data analysis. We develop or help developing tools to integrate and scale scientific use case. And we provide access to innovative infrastructure and technologies. I'm part of the operation team at 3IT, and we currently provide access to an OpenStack deployment, to Ceph clusters. We have several HPC-like resources, and a timeshare on the CSCS Spitzdane supercomputer in Lugano. So our journey starts with our HPC resources. We started it very small in 2014 with a single SGI node. That was part of the batch queue system, so single partition, single node, very easy. So we had an NFS file server, the usual HA setup with 2 boxes and some JBOD connected with fiber channel. Then we actually increased our node count, and we got basically 11 nodes, all sharing initially the same file server, but was exporting both home and scratch. But we soon started to see that the setup was not working as we wished. So we actually coupled it with the ZFS file server that was connected via an SAS expander. This actually splitting home and scratch meant that at least we decoupled the 2 file systems, and issues on one wouldn't actually degrade the performance on the other. As we were expecting additional node in 2018, we decided that we needed to actually make a big overhaul of our storage system. So we go back to the blackboard and started actually laying out requisites. We came out, of course, with POSIX compliance. After all, it's an HPC environment. We wanted reliability, at least comparable to the one we already had, so RAID 6. We wanted expandability and scalability. That had been the main pain point in the previous setup. It was not easy to expand and much less so to scale. We wanted performance because it's an HPC environment and users have certain expectations we wanted to fulfill. And we wanted it to be cheap. So we wanted to avoid expensive licenses. We also came up with a list of nice-to-have points. We wanted to be decoupled, meaning that the surge of traffic to a specific directory or file system should not cause a degradation in other part of said system. We wanted to have quota support because to actually keep the system usable, you have to keep it from filling up. And we wanted to have a mechanism to give users access to their data from machine we don't control directly. So all of these requirements actually left out the most important one. We want flexibility. We want a tool that actually can help us to keep up with ever-changing requirements. We don't run a regular HPC supercomputer where for 5 years the requirements are basically set in stone, but we constantly have a changing landscape, and we need to adapt to it. So why did we pick Ceph? We've been using Ceph for a long time as the backend storage for our OpenStack deployment. We had no trouble actually realizing that it was reliable and was expandable and scalable. And on top of that, we actually saw the new Luminous release nodes, and so that we were so packed with features that we liked. In particular, the erasure-coded pools that were supporting overrides. So that means that we could move away from a replication policy and move to like an erasure coding policy, thus saving, having less overhead in storage space. And regarding more in detail CephFS, we saw that some of the features were very, very enticing, like the multiple active MDS support, the fragmentation for directory, and the ability to pin specific directory to specific MDSs. So we started at the end of 2017 with a small testbed. We used the nodes that we were using at the time for our main OpenStack cluster. Those are like basic regular nodes with SSDs for journals, for a total of 72 SSDs running on spindles. And we started from a dual release. The reason for that is that CephFS was deemed finally stable in that release, and it was only one release away from our production cluster, but at the time was running Hammer. We devised a series of synthetic workload to mimic the code run by our user. Basically, that included metadata-heavy operation, moving big files, and concurrent access and modifications. The first issues that began to surface then, and we've been actually, we plugged them one by one. The one that we remember more clearly are the slow metadata access that was compromising actually the performance of the whole cluster. We naively thought that we could use the nodes we're using for RBD in our OpenStack deployments as they were. So we actually created a metadata pool that was on the same storage used by the data pool. That didn't work quite well enough. So we added an NVMe to each node for the metadata pool, and the situation got dramatically better. The other problem we remember is this message that probably many of you have seen if you tried CephFS, that is failing to respond to cache pressure. At the time, we actually solved it quite easily after a lot of reading, a lot of struggling, upgrading to Luminous, but actually we hit that back later on in our journey. All our tests actually provided us with a good overview of what CephFS was capable of, and we came up with some key decision. So we decided that we did not want to integrate CephFS into the existing Ceph cluster for two main reasons. We wanted actually we're still new to CephFS, so we wanted to roll out new features, but we didn't want to impact the whole infrastructure with those, and we wanted to limit it to just the HPC infrastructure. The other reason for that is the HPC infrastructure is something we control very closely. We control also the backup of such infrastructure. We didn't want to wait also for the upgrade of a main cluster. As you remember, we started with Jewel in the testbed, but we realized that we had to deploy at least Luminous, and that would already been 2 steps away for our production cluster. We also decided that the Fuse driver was not cutting it, and we had to use the kernel driver. And as time was passing and the Mimic got released, we decided to opt to deploy directly with that release that had quota support for the kernel driver. So what about our production deployment? We started a new cluster, so 3 monitors, 120 SSDs divided in 10 servers, and high endurance NVMe for both RocksDB and the metadata pool. And we actually used 2 MDSs from an existing purchases we had. Those actually turned out to have 2 little RAM for our needs and caused a lot of pain later on. We actually also reused 40 solid state SSDs with the idea of actually have a separate file system for those. We tried to get the new nodes a single socket, but because we were reading about the magic of not having to deal with NUMA for Ceph, but the vendor came up at the end with some excuses, and actually they gave a second processor for free. So we didn't have a chance to actually test those. So that's how our deployment worked. We deployed in stages. In January this year, we deployed the first file system. So we decided to go with a multiple file system. And we deployed the SSD-backed file system in January that was meant to actually take over home and data, so from the previous system. In February, then we developed the bulk of of nodes, as you can see from the blue line that actually goes very much up. And then in May, actually, we realized that the hardware we bought for this purpose was not sufficient. So we actually used some of the nodes from our Ceph pool, the one that are meant to expand the main cluster for CephFS. Okay. The main pain point we had was quota. As you remember, we deployed Mimic because of quota support. We knew that we needed a recent kernel. We didn't actually realize that to have it in production, that would have meant to upgrade everything to Ubuntu Bionic and also to have the hardware enablement image for Ubuntu Bionic. So we're still working on that, but in the meantime, we needed a solution and a fast one. Because as you can see on the blue line on this graph, that is actually the object count per pool, and that's still like the flash storage. And it happened like quite a few times that users were mistakenly filling up the whole file system. We are talking about just 40 SSDs of 1.6 tera, so not so much space. We used the replica free for both, so it's actually a third of the total. And we decided so to actually use the extended attributes. We created a script that can give the users an immediate outlook on what their usage are in terms of storage. We also had a wrapper to show the information at login. And we start delaying login for users that were over quota. But actually, it's been a very successful approach. You can see the blue line flatlining, like since middle of July when we deployed this wrapper. And actually, it's not because there's no more movement on the file system, but because actually users try to stay within their bounds. So what did we learn from these journeys? On the design side, we really understood that the fastest storage you can afford for your metadata, the better you're off with. Users don't like to wait for listing directories or for other operations that are usually associated with a broken file system. So if you actually can give them an immediate result, your user will be happy. MDSs should actually have enough RAM and computing power, as they easily become the single point of failure for the entire cluster. The multi-MDSs feature can help, but it doesn't do miracles. Multi-active MDSs, as Dan actually outlined earlier today, works better if you can foresee the hotspots, or at least you can statically pin directory to them. The automatic balancer works, but sometimes it doesn't do exactly what you expect it to. We deployed more than one file system. We thought it was a brilliant idea at the time. But it's still experimental, at least in Mimic. I don't know if there are plans to actually stabilize it. We realized we don't really need it. In our case, it does not provide any clear advantage. The RocksDB partition size. So when we bought the hardware, recommendation was to have 1% of the available space on Spindle for RocksDB. When we actually received the hardware, that recommendation was bumped to 4%. So we're like, oh, and now what should we do? We decided just to go with what we had, and it turned out it was okay. Of course, you should not have partition that are too small, otherwise you incur in performance penalty. Regarding the operation side, of course, we already have an idea that the Ceph deals with the disk failures in a nice way, but we actually have the chance to try it again and again over the last year, as apparently we got a batch of botched disk. Despite them being enterprise, we had like 80 failures over 200 disks, so quite a large number. You should not use DU unless you really need to. There are better options, like using the extended attributes to retrieve the amount of data stored in a specific directory. The extended attributes themselves are amazingly convenient to set a bunch of parameters like quotas, directory pinning, and others. And your Ceph.conf should always be treated with extra care. Some option can have confusing name. For example, the MDS cache size and MDS cache memory limit hit our production cluster when we mistaken one for the other, and we limited the MDS's inode number to a low value. Kernel clients are not properly identified by the Ceph feature commands, or at least not yet. So for example, if you want to use upmap on your cluster, despite the output from Ceph features, if your kernel is recent enough, you can enable it. So what's the current status? We have a bunch of nodes we added on top of the one we already have. We plan to add more later this year. Everything is actually working on CephFS, with CephFS that serves both home and scratch, and data as well. And what are our future plans? We actually want to move away from the multiple file system setup we are using now and leverage the multiple data pools support of CephFS. Namely, we want to actually try to make it cheaper. So we want to add a pool with more aggressive erasure coding and with no NVMe, with compression as well, and actually rely on the existing nodes for the metadata pool. We want to make it simpler, as I was saying, no use for us for a second file system, so we want to deploy the flash tier storage as well as the data pool. We also want to make it more tolerant to user mistakes, so to provide a periodic snapshot, user accessible, to retrieve the data previously deleted or modified. So that concludes my presentation. Are there any questions?